Good morning children. Today I am going to start with the chapter Ray Optics, which is the first chapter in your part 2 textbook of physics. Now ray optics is a portion which deals with the study of light, and in standard 10 you have already studied a portion of the ray optics. So this class will be a kind of revision in the first part. So let us start the class. In standard 10, in ray optics, you have studied about plane mirrors, their reflection. In standard 12, we are going to study about spherical mirrors. Spherical mirrors are of two types, concave mirror and convex mirror. Concave mirror, this is the reflecting side. Ray of light passing through the concave mirror gets reflected from this side. And in convex mirror, this side is polished and this side is the reflecting side. So concave mirror, the cave side is the reflecting side. Convex mirror, the bulging side. Now, in spherical mirrors, we have to be familiar with a few terms. So we are going to learn the few terms related with spherical mirrors. First term is called the pole. Pole of a spherical mirror. Now, a spherical mirror is a part of a big sphere. Okay, it is a cross section. A sphere, when you cut a portion of the sphere, you get a spherical mirror. If this side is reflecting side, it becomes concave mirror. If this side is the reflecting side, it becomes convex mirror. Okay. So, let me tell you what is the pole of a spherical mirror. Pole of a spherical mirror is the actual geometric center of this spherical mirror. The geometric center of the sphere is called the pole. So, pole is the geometric center of this spherical mirror. Next, center of curvature. Center of curvature of a spherical mirror is the center of the sphere. I told you the spherical mirror is part of a sphere. The actual center of the spherical mirror is called the center of curvature and is represented by the letter C. So, center of curvature is the actual center of the sphere of which the mirror forms a part. Next is radius of curvature. Now, radius of curvature of this spherical mirror is the radius of the sphere of which the mirror forms a part. So, radius of the sphere of which the mirror forms a part, that is called radius of curvature of this spherical mirror. Next is principal axis. Principal axis is the straight line passing through the center of curvature and the pole. Remember, the spelling of principal axis, it's not principle like Archimedes principle, not PLE, but PAL, similar to the spelling of your school principal, the sweet old lady who is talking to you right now. Okay, so principal axis is a straight line passing through the center of curvature and the pole. The same is applicable to convex mirrors also. This is a convex mirror. It also has a pole, the center of the sphere, center of curvature, the center of the sphere of which the mirror forms a part, then radius of curvature, the radius of the sphere, and principal axis, a straight line passing through the center of curvature C and the pole. So we have studied about 4 terms. First one is the pole. Pole means the actual geometric center of the spherical mirror. Center of curvature, it is the center of the sphere of which this spherical mirror forms a part. Radius of curvature, it is the radius of the spherical mirror, the sphere of which the mirror forms a part. And last one is principal axis, a straight line passing through the principal pole and the center of curvature. Principal axis, straight line passing through the pole and the center of curvature. So, pole, center of curvature, radius of curvature and principal axis. I hope you have learned these 4 terms. This is a sample of a convex mirror and this is a concave mirror which you will be handling yourself while doing experiments in your physics practicals. Now, let us move on to focus of a convex mirror and a concave mirror. What do you mean by focus? When a ray of light passing parallel to the principal axis falls on a concave mirror. After reflection from the concave mirror, it meets at a point on the principal axis. This ray of light is parallel to the principal axis and very close to the principal axis. After reflection, it passes and meets at a point on the principal axis, and this point is called the focus and represented by the capital letter F. In case of a convex mirror, when a ray of light passing parallel to the principal axis falls on a convex mirror, it does not meet at a point. Instead of that, it gets reflected away like this. It gets reflected away, but it appears to diverge from a particular point. It appears to diverge from a point on the principal axis, and that point is called focus of a convex mirror. So focus of a convex mirror is a virtual point, while focus of a concave mirror is a real point. Actually, the ray of light is meeting at this point, and the distance between the focus and the pole is called focal length, and it's represented by small letter f. Now let me tell you that this point focus is exactly in between the 2 points C and P, that is center of curvature and the pole. So focus is in between C and P. That means distance CP is the radius of curvature capital R. So focal length is half of radius of curvature. Focal length is half of radius of curvature. So since focus is in between this line CP, where CP is the radius of curvature, focus or focal length is half of the radius of curvature. So the two terms, focus or principal focus of a concave mirror, principal focus of a convex mirror, and what is focal length, relation between focal length and radius of curvature. I hope you have understood these two terms, focus of concave mirror, convex mirror, and focal length. Now let's move on to construction of images using ray diagram. First case 1, when the object is placed between the focus and the pole. See, when the object is placed between the focus and the pole. For that, we have studied about construction of ray diagrams. A ray passing parallel to the principal axis. After reflection, it passes through the focus. And a ray of light passing through the center of curvature. After reflection, it retraces its path or it gets reflected back. And where do these two rays meet? They appear to meet at a point behind the mirror. So this is the point where they are meeting. So this is the position of the image. Now let us see what are the characteristics of the image formed. The image is formed behind the mirror. It's a virtual image. That means the rays of light are not actually meeting. It is erect or upright, and the image is a magnified image. Next, when the image is placed at the focus. When the image is placed at the focus, let us find out when the object is placed at the focus, let us find out where the image is formed. To find out the image formed, let's draw a ray of light passing parallel to the principal axis. After reflection, it passes through the focus. A ray of light passing through the center of curvature. After reflection, it retraces its path. So you can find out that these two rays are two parallel rays. Where do two parallel rays meet? The parallel rays meet at infinity. So the image is formed at infinity. Since the two rays, we say that they meet at infinity, we say that the image is a real image. Since it's formed at downwards, we say that it's an inverted image, and it will be a highly magnified image. Next, when the object is kept between focus and the center of curvature. When the object is between the focus and the center of curvature, let us find out where the image is formed. As usual, a ray of light passing parallel to the principal axis. After reflection, it passes through the focus. A ray of light passing through the focus. After reflection, it passes parallel to the principal axis. And they actually meet here. So, what are the properties of the image formed? The image is formed beyond C. It is a real image. Actually meet, the rays are actually meeting. It's an inverted image downwards and a magnified image. The image is bigger than the object. Next, when the object is placed at the center of curvature. When the object is placed at the center of curvature, let us find out where the image is formed. A ray of light passing parallel to the principal axis. It passes through the focus. A ray of light passing through the focus passes parallel to the principal axis and it meets here. That means at the center of curvature itself. So where is the image formed? The image is formed at the center of curvature. It is real and inverted. What about the size? It is the same size as that of the object. Next case, when the object is kept beyond the center of curvature. The object is kept beyond the center of curvature. Where is the image formed? A ray of light passing through the focus. After reflection, it passes parallel to the principal axis. The next one, a ray of light passing parallel to the principal axis. After reflection, it passes through the focus. So, the two rays meet over here and the image is formed here. So, where is the image formed? Image is formed between the focus and the center of curvature. It is a real and inverted image. And what about the size? It is diminished, smaller than the object. If the object is at infinity, we can't mark the object in our diagram. So instead of that, we mark two parallel rays coming from infinity. And the two parallel rays, after reflection, it passes through the focus. So we say that the image is formed at the focus. It's a real image. And what about the size? It is highly diminished to a point. Next, construction of image for a convex mirror. Construction of image for a convex mirror is similar to that of concave mirror. Only thing is, when an object is placed in front of a convex mirror, a ray of light passing parallel to the principal axis, after reflection, it is reflected away like this. Unlike in the case of a concave mirror. It is reflected away and it appears to come from the focus. Okay? It gets reflected away in such a way that it appears to come from the focus. And the next ray, a ray of light passing through the center of curvature. This is the center of curvature. And a ray of light passing through the center of curvature means a ray of light coming like this, falls on the mirror, and it reflects away like this, reflects back, but it appears to come from the center of curvature. Okay, so these two rays, these two imaginary lines appears to meet over here. Okay, so this is the position of image for a convex mirror. So where is the image formed and what are the characteristics? The image is formed between the focus and the pole. It's a virtual image. It's an upright image. It's smaller than the object, so it's a diminished image, and it is formed behind the mirror.